Hello everyone. Am I audible to you? Mhm. Hello. Hello. Okay, my dear friends. So we are going to start now. Yeah. So my dear friends, today is the lecture number 6 of current electricity, and as I told, we will discuss today about electrical instruments. Yeah. Hello Ansab, how are you, my dear? I'm fine. I'm good. How are you? So today we are going to discuss like ammeter, voltmeter, meter bridge, potentiometer. These things we'll discuss. Hi Mohammed Ayub. Good evening, my dear. Yes. So my dear friends, let us start quickly. So at first, I would like to welcome you all. Welcome to Unacademy. Unacademy is India's largest learning platform where you can prepare for the various competitive exams with the help of the top educators of the country with the quality content and great learning experience. So, let me introduce myself. My name is Rahul Dagariya. I have been teaching physics since 5 years in the various reputed institutions of India. Till now, I have mentored to the thousands of aspirants of NEET and IIT J. And now, I am available here to help the students of the country to learn the concepts of physics for NEET UG with the best notes and best examples. So, let us talk about this. If you did not download the Unacademy app yet, please go to Play Store and download it. Next. Plus subscription, all of you know about this, right? What is plus subscriptions? You'll get daily live classes and live tests and quizzes, structured courses, and unlimited access to the live and recorded courses, right? All of you know about that. Yes, my dear. Today, from current electricity, this is the last lecture. Okay. Yes. So now next I'll talk about the iconic subscription, my dear friends. Yeah, here you are getting all plus benefits, but apart from that, you'll get a personal coach, test analysis, in detail analysis. You'll get the study planner. You will get. Okay, my dear friends. Now, let us compare these both. So, on Plus subscription, you are getting India's best educators, interactive live classes, structured courses, and PDF, live tests and quizzes. On Iconic subscription, you are getting all the Plus benefits, but apart from that, you are getting a personal course, study planner, expert guidelines, and test analysis. Okay, my dear friends. So, let's move ahead. Iconic subscription, 12 months and 24 months subscription available. But last day, tomorrow 6 p.m. it will increase. Okay, the prices will increase. Yeah, so 45,000 for 1 year, and for 24 months it is 61,000. Using my code Rahul D, get 10% discount till 31st October. Okay, yeah, till 31st October you'll get the discount, but these prices are going to rise tomorrow only. Okay, so you'll get what, 40,500 rupees, and 2 year subscription 54,900 rupees. So my dear friends, let's move ahead. NEET UG subscription, its prices are also going to increase. Okay, my dear. So listen, it is available for 1 month, 3 months, 6 months, 12 months, and 24 months. Okay, for 1 month 6,000 fee, but 5,400 you need to pay using my code Rahul D. 6 months subscription, 24,000 is the fee, but using my code Rahul D, you need to pay 21,600 rupees. Now, using my code Rahul D, you need to pay 27,000 rupees for 1 year and 32,400 rupees for 2 years. Okay. Yes. So these prices I told you, I told you, these are going to increase. Okay. So my dear friends, if you wanna get an academy subscription, get is as get it as soon as possible. Okay. Yeah. Means tomorrow 6 p.m. You know. This is just for your information. Okay. Tomorrow 6 p.m. Your wish, which word you want to use, whether you want to use or not, it's your wish, right? But its prices are going to rise. That's all, my dear friends. Today we are going to talk about electrical instruments. At first, we will start with the galvanometer. Okay, galvanometer. So, my dear friends, listen. Galvanometer is like a very simple device. Okay, what happens? Listen. So there is a device. It looks like this. In that a coil is there. In that, a coil is there, and which is attached with a magnetic like needle. Okay, it is attached with a magnetic needle. Okay, whenever current is flowing through this, current is flowing through this, the magnetic field inside it changes. As magnetic field inside it changes, then the needle deflects. Okay, so simply speaking, galvanometer just shows the magnitude of, actually it will not give you any value. It will just show you that how much current is flowing and in which direction it is flowing. Okay, so it will give you the direction of current, and like it will compare to magnitude. Simply speaking, it will give you the magnitude. Okay, let's say for 1 ampere current is this, its deflection is this much. For 5 ampere current, its deflection will be this much. So for different currents, its deflection of the needle will be different. Okay, so simply like you have seen, uh, you might have seen in your labs, right? Like zero here, here 1, 2, 3, 4, like that, and this side 1, 2, 3, 4, 5, like that. Yeah. So initially it was at middle here. Okay, when no current is flowing, it is like this. When the current is flowing, it will deflect either left or either right. It depends on the direction of current. Okay, my dear friends. So such a device is galvanometer. It will just give you the give you the idea about the strength of the current or intensity of the current. But it will not give you value. It will give you the strength of the magnitude, right? Yeah. Next, it will give you the direction information also. That's all. So simply, my dear, here something written, but these things you can learn only after the magnetism. Okay, but still I am just introducing this, my dear friends. It is completely based on torque. Okay, it is completely based on torque of the needle. Torque of the needle due to a magnetic field. Are you getting? Because whenever you are providing the electric current, in that magnetic field will be generated, and because of that magnetic field there will be a torque experienced by the needle, and it will deflect. It will deflect. Okay. Yes. So B here I have written a simple formula. Torque due to magnetic field should be equal to torque due to spring. Actually, as I told, there will be a coil. Coil means there will be a spring inside the galvanometer. Okay. Yeah. So this both should be same. So simply speaking, BINA, है ना? BINA sine theta is equals to C phi. So definitely you don't know these things properly now. You will learn it anyhow in magnetism chapter. So just giving the information, I have written the formula. Just I wanted to say I is proportional to phi. This thing you need to remember. I is proportional to phi. Okay. I means current. Okay. And okay, no problem, answer. Yeah, I is current, and this phi is deflection of the needle. Phi is the deflection of the needle. So that's all. This is the thing you should remember. Else nothing is that much important. Anyhow, you will learn this thing in the magnetism and all, right? Yes. So let's move ahead. Current sensitivity. Don't worry. We will just use galvanometer with the other devices to make ammeter and voltmeter. That is important. Okay. Alone galvanometer is not important. Yes. So current sensitivity, an important like definition, you should remember it. What is current sensitivity? The ratio of deflection of the current, that is deflection per unit current, is called current sensitivity. So current sensitivity CS, that is deflection, yeah, per unit current. So let's say deflection is phi and current is I. Okay. So current sensitivity of galvanometer is deflection divided by current. Okay. That's also this formula you remember? Yes. Rajni, कितना रह गया है? This is electrical instrument. We'll finish it today. Okay. We'll finish it today. Today we'll finish it. Okay. Yes. After that, I'll be tomorrow and day after tomorrow. Two lectures are relative motion lectures. Okay. 2 days relative motion lecture will be there. Yeah. So let us talk about this current sensitivity. We have written its formula, right? Current sensitivity is pi upon I. Okay. Yes. So we have just started, nothing left. Okay. Even you don't know these things, then also okay. Galvanometer is just a device which give you the information about the direction of current and the magnitude, right? Oh no. You know you did not miss anything, Rajni. You did not miss anything. Okay. You did not miss anything, my dear. Okay. Yes. So now, these formulas are okay, not needed at all now. You will learn this thing in moving called galvanometer in magnetism and all chapters, so no problem about that. Current sensitivity is phi upon I, means the deflection of that particular that we can say needle upon current. Okay, that's all. So anyhow, galvanometer, yeah. So this is important in entire these two slides. The most important thing is this: the galvanometer gives the information about the current and its direction. Okay, for NEET students, this is only important. Else all are just okay. Okay, this all if you don't remember, then also okay. No worries. Okay. Yeah, so remember this, galvanometers gives us information about the current and its direction. That's all. So this is the important point. Next, ammeter. Yeah. So what is ammeter? Ammeter is a device which is used to measure the current and how much current is flowing through a resistance or how much current is flowing through a branch, a wire, that we use to measure using the ammeter. Okay, right? So representation of ammeter is like this. You can see. So we can convert it. Listen, representation of ammeter. Okay, yeah, it is like this is ammeter. Okay, it just looks like galvanometer only, or we can say we can form a ammeter using the galvanometer. Okay, yeah, so its explanation is written here. Just remember this and this is very important. This is very important. Okay, listen, a shunt means a small resistance or any resistance. Okay, but for a meter you need small resistance. Yeah, a shunt or small resistance is connected in parallel with galvanometer to convert into a meter. So let's say you have a galvanometer. Okay, you have a galvanometer. Now what you will do, if you connect a very small value of resistance in parallel with this galvanometer. So this is shunt. This resistance is called shunt. Okay. So combinedly this shunt and this galvanometer are called ammeter. Okay. It will form an ammeter. Okay. So it can be used to measure the current in a circuit. Okay, my dear friends. If you got this, please give thumbs up, my dear friends. That's all. So very simple thing. A shunt resistance is added parallel to the galvanometer, then it is called ammeter. It will behave as an ammeter. That's all. Very simple concept. Okay. Yes. So yeah. So an ideal ammeter always have zero resistance. My dear friends, as I told you, an ideal resistance will always have a zero resistance. Okay, that you need to remember. Next, ammeter is represented as follows. So as I told you the diagram, right? A galvanometer is there, in parallel with that a shunt resistance is connected. Okay, so this entire system is known as what? Ammeter. That's all. So let us talk about it further. So my dear friends, this I have taken ammeter. This complete system is ammeter. So I am saying, let's say current is coming towards galvanometer, that is I is total current. Okay, no problem. I am saying galvanometer is having some resistance, that is Rg. I don't know what is that, but in question it will be given. So let's say resistance in the galvanometer is Rg and current flowing through galvanometer is Ig. Okay, and current flowing through shunt will be how much? I minus Ig. Okay, so now what to do? So simply speaking, we are having resistance and galvanometer resistance. From both of them, current is flowing, both are in parallel. It means I will say the voltage difference, yeah, potential difference across galvanometer is same as the potential difference across the shunt. So you can write Ig into Rg, that will be equal to I minus Ig into S. Yes. Array yaar, simply potential difference is same across both. Okay, so now what can you do? So just write it. So Ig common, you are getting what? Rg plus G. Okay. Sorry, this is S, hai na? This is S. Yes. So Rg plus S you are getting here, and here you are getting I into S. Okay. So finally, if you want to find the what is the current? Now, what is the current? I. So I will be equal to what you will write? Ig into, yeah. So you can write it directly, hai na? Just simply we are using Ohm's law, nothing else, right? So that's all. The maximum current is measured by, we can say, Ig into Rg, right? And I minus Ig. So I is maximum current. Okay, simply. So we are getting S is equals to IGRG divided by IGRG divided by I minus IG. Okay, that's all right. So this is the thing we wanted to explain, right? Next, I am saying let's say I is greater than IG, means I current is very greater than IG. Now, obviously, so what will happen? So you need to find this current, right? You need to find this current. Okay. So what you will do? So this only I have written. Let's say shunt resistance is very small. Shunt resistance is very small means what will happen? Means what will happen? Yeah, shunt resistance is very small means maximum current will pass through this only. Okay, right? So you can say S will be equal to IGRG upon I. This is just shunt resistance, है ना? Right? If you want to measure a current, just you need to use this. That's all. Hey guys, whatever I am telling, it may confuse you. So simply you remember this much only. Okay, what is going on? A galvanometer is there, a shunt resistance is in parallel with this. That's all. This is called ammeter. Okay. Let's say total current is coming, that is I, and current going in this is Ig, its resistance is Rg. Now the remaining current will go in this direction, so I minus Ig will go in this direction, and this is S. Okay. We know potential difference across galvanometer and shunt will be same. So directly we'll say Ig into Rg is equals to I minus Ig into S. That's all. S for shunt resistance. Okay. That's all. And Rg is resistance of galvanometers. Right. So that's all. You can measure the value of I. You can find the value of S. That's all. Right. So that we have done, my dear friends. That's all. Now, for measuring the current, है ना, the ammeter is connected in series. My dear friends, listen. What is the meaning of this statement? Let's say I have a circuit like this. Okay. So I am saying this is something V volt battery, and here I have connected a meter. है ना? This is a meter. So and here is a resistance. Here is a resistance. So simply speaking, this is resistance R, and I need to find the current in this branch, है ना? The current in this circuit. So I will just add this resistance and this ammeter in series. Okay. So resistance and ammeter should always be connected in series. Hello Hedvi, how are you? Next, I am saying let's say this is R1 resistance and this is R2 resistance. Okay. Right. Now the question is, if this I am saying let's say E volt. Okay. If you want to measure the current, current flowing through the battery, what you will do? So you will just add an ammeter in series with this battery. That's all. So this is A1. Here I'll add A2. Okay. And here I'll add A3. Okay. So A1 will give what current through the battery? Current through the battery. Okay. Through the battery. Okay. Yes. Next, A2 current through R2. A3 current through R1. That's all. So these things I have written here. Okay. Remember. I am good. Just little fever. Oh my God. Take care. Get well soon. Yes, my dear. So now resistance of ammeter. Let us talk about it. Right. Hey. One more thing. If you have given a shunt resistance and a galvanometer, and you want to want to find the current in a circuit, what you will do? So I'm saying let's say this is R resistance. Okay, this is voltage battery, right? E. Now you need to find the current in this circuit. So you'll think I'll add a meter here. Means I can add like this. This resistance. Here I'll add what? Here I'll add what? Yeah, this is galvanometer. Okay, and this is shunt. This is the same battery, and like this. Simply you got this. This entire, this is called what? It is called ammeter. This is called ammeter. Shunt and galvanometer are in parallel with each other, but this entire is ammeter, and ammeter should always be connected in series in any branch to find the current in that branch. Okay? Yes. Hi Kalai, how are you? So that's all, my dear friends. So let us talk about this. Ideal ammeter is equivalent to zero resistance wire. Okay, remember ideal ammeter. You know, in an ideal ammeter, I will say it is always equivalent to zero resistance wire. Okay, there will be almost negligible resistance or very less resistance. Okay, yeah. So next, yeah. So the same thing, right? So I am saying, let's say this is ammeter. So I am writing here. Let's say this is shunt and this is galvanometer. So you can say total current is coming towards this. Yeah. So I will say, okay, let's say total resistance of this is RA. Is RA. RA means resistance of what? This ammeter. How can you find? So you can say 1 upon RA. This is equivalent resistance of 1 upon RG plus 1 upon S. है ना? Because this is S and this is RG. So simply you will get this is equivalent resistance. Means resistance of ammeter can be given by this formula. Okay. S into G divided by S plus G. That's all. Yes. So my dear friends, if shunt is very small, because shunt is very small, it means it is leading towards ideal ammeter. Okay. So for ideal ammeter, shunt should be almost zero, very small. Okay. It will measure better current. Like yeah, more accuracy it will give. Okay. Next, there is a question in front of you. What is the value of shunt which passes 10% of the main current through the galvanometer? So in question it is given कि this is total current I, okay, no problem. This is galvanometer, okay, no problem. This is shunt, no problem. So in question it is given that Ig is this galvanometer current and this current will be what? I minus Ig. I minus Ig. Okay. This is shunt. So the question is, what is the value of shunt? Find the value of shunt. I am giving you four options A, B, C, D. Come on, you can do it. I have already explained you the basic things, right? You try to find it. So I am giving you options, my dear. So the yeah, 10 ohm, 21 ohm, 11 ohm, and this is 110 ohm. Which of the following is the correct answer? Come on, con choose the correct answer. You need to find value of shunt. Okay, what is the value of shunt which passes 10% of current through the galvanometer of 99 ohm? Means Rg value is given. Rg is 99 ohm. Okay, my dear, it is given in the question. Yes, Rg is 99 ohm. You need to find the value of S. Come on, you can do it. Yeah, waiting for your response, my dear. Come on. I have already. Anyhow, even you don't know a meter, but you can find just by seeing this diagram, right? Because you have studied the current electricity. Okay, anyhow, I'll solve it, but have patience. I'm just counting till 5. 1, 2, 3, 4, 5. Very good, Kushi. Answer is D for dog, 11 ohm. Very good. Correct answer. Correct answer. Okay. Now it is given in the question, yaar. Okay, this is shunt. Okay. This is galvanometer. Okay. Let's say current going through this is Ig and its resistance I am saying, let's say that is Rg. Now current going through this shunt will be what? Let's say total current is I. So it will be I minus Ig. है ना? We have already yeah, we have already done this. Yes. So in question it is given that Ig is 10% of main current, means Ig is I by 10. Ig is I by 10. Okay. Yeah. The value of shunt which passes 10% of current through the galvanometer, right? So simply, so what to do? So just I will say potential across galvanometer and shunt will be same. So Ig into Rg will be equal to I minus Ig into S. Simple. So what to do? Just put the value. So you'll write I by 10 into Rg. Rg is given in the question 99 ohm. Okay. That will be equal to I minus I by 10 into S. Value of S we have to find. So directly I can say This all things will be cancelled. You will get 99I is equals to 9S. So S is equals to, sorry, 9IS. Yeah. So you are directly getting here S is equals to 11 ohm. That's all. This is the answer. Very good. Okay. If you got this, please give thumbs up, my dear friends. Come on. Kalai, Hetvi, all of you, please give thumbs up. Yes, yes, yes. Okay. So to make an ammeter from a galvanometer, we always need to add one shunt resistance of small resistance in parallel with the galvanometer. Okay. Right. That's all. Now these are two circuits in front of you. Question. Find the current in A and B both. है ना? First, I am writing for A. है ना? Yeah, for A. Current in A, you tell me. Current in A, you tell me. First diagram. है ना? Just asking for first. A, B, C, D, four options. Come on. Give me the correct answer. What is the answer for this? 5 ampere, 10 ampere, 20 ampere, or 0.5 ampere. Which of the following is the correct answer? Come on. For first diagram, what is the current? What is the current in the circuit? A. What is it? Yes, very good. This is 5 ampere. And a very, very, very simple question it is. Yeah, Ohm's law, Kirchhoff's law, whatever you say. So I will say 10 ohm, 10 volt battery, 2 ohm resistance. So I is equals to 10 by 2. है ना? I is equals to V by R. V is equals to IR. Na? So you will say 5 ampere over. Now, current in this circuit. Come on, tell me. What is the current in the B circuit? Yes, waiting for your answers. A, B, C, D. Four options are there for you. 5 ampere, 4 ampere, 10 ampere, 2.5 ampere. Which of the following is the correct answer? Yes. My dear friends, come on, give me the correct answer. What is the current in, yeah, what is the current in this second circuit, or we can say current measured, है ना, by the ammeter. Come on. What is the current measured by ammeter in the second circuit? Yes, yes, yes. Khushi, come on, answer me fast. We always know that this is a meter. A meter means net resistance of galvanometer, equivalent resistance of galvanometer and shunt. Finally, we are getting this. Okay, 0.5. Okay, so I will say that ammeter is always added in series with any resistance to find the current. Okay, so I will say that this is 2 and this is 0.5, so 2.5 in series. 10 divided by 2.5, you are getting 4 ampere. Answer is B for all. That's all. This is the answer. Okay. Yes. So finally, you got in this circuit, current is 5 ampere. In this circuit, current is 4 ampere. Okay. You can see circuit is same, but in first circuit, there is no ammeter. In second circuit, there is an ammeter of 0.5 ohm resistance. Chalo. Find the percentage error. Find the percentage error in measuring current through the ammeter. If ammeter is measuring the current, what will be the percentage error? Can you find? So I will say percentage error in finding the current. है ना? So delta I divided by I into 100%. Right? Delta I will say कि 5 ohm should be there, but only 4 is flowing. So 5 minus 4 divided by 5. है ना? Actual current minus measured current divided by actual current. So I will say this is 1 by 5 into 100%. है ना? So directly you will write what? 20% is the answer. 20%. This is the answer. Very good, Khushi. Very good. Next question is there in front of you. Here, ammeter is connected parallel to the 6 ohm resistance. You know? So there are two questions. First, find the reading of ammeter. Come on. Find the reading of ammeter. I am giving you options. Find the reading of ammeter. Waiting for your answers. Okay. Ready? So find the reading of ammeter. Yes. These are the four options in front of you. Choose the correct answer. What is the reading of ammeter? Actually, ammeter should be added in series, but by mistake, someone added in what? Parallel. Yes. Okay. Yes. So the reading of a meter you need to find. Reading of a meter, है ना? So Khushi, we are going to check it. Okay. So I am saying कि what is the equivalent resistance of this entire circuit, है ना? So I will see कि current flowing through battery. Okay, that will be equal to total voltage of battery divided by equivalent resistance. So equivalent resistance will be what? 6 and 3, and ammeter is having 3 resistance and this resistance is 6, है ना? So I will say 6 into 3 divided by 6 plus 3. This is equivalent plus 1. It will be in series with this. So you are getting 2 plus 1, 3. 3 ohm you are getting. Okay. So divide by 3, you are getting 6 ampere. But my dear, 6 ampere is current through the battery. It is not reading of ammeter. It is not reading of ammeter. Okay. Because ammeter is added in parallel with the resistance by mistake. Okay. So now what will you do? So simply you will say here current is flowing 6 ampere. Okay. No problem. Here a meter is having 3 ohm resistance and this is having 6 ohm resistance. Okay. So we know one thing, current will just flow in opposite ratio. So you will say current through the ammeter. What is resistance? 6 ohm. Sorry, 3 ohm. So you will write 6 divided by 3 plus 6. है ना? अरे यार, R2 divided by R1 plus R2 is I1, right? Into total current, that is 6 ampere. So you are getting what? You are getting what? 3. 36 divided by 4 ampere. Sorry, 4 is the answer. A option is correct. A option is the correct answer for this. Okay, right? Did you get it? Yes, yes, yes. If you got this, please give thumbs up, my dear friends. You know how to find current into different branches. Do you remember? Yes. Yeah. I hope you remember. If you do not remember, I am reminding you. Just a minute. I am erasing this all. You remember that I told you in the previous classes. Let's say this is R1, this is R2, and this is I. So I'm saying, let's say current here is I1, current here is I2. How to find I1? So I1 you will find like this. I1 is equals to R2 divided by R1 plus R2. Okay, R1 plus R2 into total current. Okay, this thing. Next, I2 is equals to R1 into I divided by R1 plus R2. Okay, so this is the thing you need to remember. Current always flows in just opposite order, like reverse order. Like there is 6, so current more current will flow through less resistance, less amount of resistance, right? Yes. So now next we will talk about a voltmeter. But before that, don't know why I want to ask you one more question. I want to ask you one more question, my dear friends. Will you reply? Will you give my answer? Yes. Here I am asking a question. Listen. A 10-volt battery is there having internal resistance. Having internal resistance R is equals to 1 ohm. Okay, no problem. Now it is connected here. This is ammeter A1. It does not have any internal resistance. Let's say it is having resistance. So resistance of this RA1 is, let's say, that is also I am saying that is 1 ohm. Okay, no problem. Now here I have connected a resistance here. No problem. Now I have connected one more ammeter here. Okay. Yeah, one more ammeter I have added here, and I am saying this ammeter. This is having 2 ohm resistance, and this ammeter is having 2 ohm resistance. Both are having 2 ohm resistances. Okay, my dear. Find reading of ammeter A1 and A2. Find A1 and A2. Okay, my dear. Come on, find it fast. Give me the reading of A1 and A2. Give me the reading of A1 and A2. Quite simple question. You can do it just KVL, KCL, nothing else. Okay. You just need to find the value of current passing through A1 and A2. That's all. That will give you answer. Okay. Yes. Come on. Find it fast. So simply speaking, you can do it, my dear. Come on. Find the current passing through A1 and A2 means reading of A1 and A2. Okay. A1 3.3 ampere. Very good. Yes. Yeah, so we are going to solve it. Listen, my dear. I will see if this entire resistance is having equivalent resistance, R equivalent. How much? This is 1 ohm, 2 ohm. Okay. This 2 will make 1 ohm. Okay. Because these are in parallel, right? This and this are in parallel. So R1, R2 divided by R1 plus R2 will give 1. So 1 plus 1 plus 1, you are getting 3 ohm. So this is 3 ohm. So I will say total current flowing through the battery. You know, battery. Okay, that is equal to 10 volt V by R, है ना? So 10 divided by 3. Okay, no problem. So I will say reading of ammeter 1. So it is the same branch, the same current I is flowing, right? So it will give you the same value. But that will be equal to 10 by 3 ampere. No problem. Now, reading of ammeter A2. So I will say the current I is coming here. Okay, no problem. This is I current. Here 2 ohm means equal current will be distributed. So I by 2 will go this side, I by 2 will go this side. And the same current means equal amount of current will be divided. Yes, so you are getting what? Directly you are getting I by 2, I by 2 means, yeah, so directly just divide this by 2. So 5 by 3 ampere is passing through A2. That's all. Okay. Yes. Very good. So what you are getting? 3.33 and this one 1.67 ampere. Very good, Khushi. All answers are correct. Very good. So that's all quite simple, my dear. I think you can do it. Let us talk about voltmeter. What is voltmeter? Ammeter you got? Ammeter is a device used to measure the current. It should always be added in a branch, like in series combination to find the current in that particular branch. Okay? Yeah. How to make ammeter? Use a shunt of small resistance and a galvanometer in parallel combination. Okay? Oh, Kailash Kadwani, thank you, my dear. Yes, my dears. So that's all. Now let us talk about voltmeter. So now we are going to talk about voltmeter. है ना? First, high resistance should be put in series with the galvanometer. Did you understand? Galvanometer is there in both the device, both the instruments, right? But for a meter, the shunt resistance should be added in series. But for voltmeter, for a meter it should be added in parallel. But for voltmeter it should be added in series. Okay. So I'll say this is galvanometer and this is shunt. Both should be added in what series combination? So this entire system is called voltmeter. This is called voltmeter. Okay. And let's say its resistance is, let's say, Rg. So you will say resistance of voltmeter is equal to S plus Rg. That's all. Okay. Got this. So this is a simple concept. We got it. Yes. So this is a quite simple thing. You just remember shunt and galvanometer should be in series to make a voltmeter. That's all. It is used to measure the potential difference across a circuit. Yeah. Resistor, it may be a resistance, it may be a battery, it may be anything, right? So we just want to, after this chapter, which chapter I will start? Rajni, I'll start relative, relative motion. Okay. Tomorrow and day after tomorrow, relative motion. And after that, no lectures. In 12th, no. Kushi, no lectures. Really, no lectures. Yeah, this is the truth. It's a bad news for me and you both. You know? Yeah. Okay. So it is used to measure potential difference across resistance. Yeah, that's why today I am so low. Correct. Yes, it's the truth. Okay. Sir, what happened and why? Okay, I have to leave. है ना. Actually, we use okay, we'll talk about it later, है ना. We'll talk about it later. I cannot share only on this video, so it's okay. Yeah, Khushi, I'll tell you at last, okay? Now you just focus at this, है ना. Huh. So let's move, my dear friends. So high resistance is over. Now this potential difference across the resistance should be measured. So listen, let's say I have a resistance R, okay, in a circuit, right? And this is another resistance. Let's say this is R1, this is R2, and this is E. Okay, I want to find resistance of potential difference across this resistance. So what I'll do, I'll just add the voltmeter parallel to this resistance. I'll just add a voltmeter parallel to this resistance. Okay, in parallel with this resistance, I'll get the potential difference across this resistance. Okay, that's all. So you remember this. That's all, nothing else. Yes, my dear. So now we are going to solve. Yeah. So you can see a galvanometer and a shunt resistance should be added in series to make a to make what? To make a voltmeter. Okay, voltmeter can be represented like this. Yes, so you can see here this is the voltmeter. So how to solve this? Simply it is in series. So I will say potential difference. Yeah, reading of voltmeter. Now that is Ig into R plus Ig into Rg, because current in this is what? Ig only, right? Same current I is flowing. Okay. Yeah. So Kushi, you are asking what happened. Okay, my dear. Yeah. So simply speaking, each and every each and every प्लेटफॉर्म एक्सपेक्ट समथिंग फ्रॉम अस. हमसे कुछ ना कुछ एक्सपेक्ट करता है ना सारे प्लेटफॉर्म्स. उनको चाहिए कि हम लोग इनफ रेवेन्यू जनरेट करें और प्रॉपरली हम लोग अच्छे से सब काम करें, है ना. तो कुछ पॉलिसीज हैं जो हम पूरी नहीं कर पाते हैं, सो ऐसा होता है ना. यस, सो माय डियर फ्रेंड्स, लेट्स मूव अहेड. Yes. So simply you can say V is equals to Ig into R plus Ig into Rg. Okay. You need to find voltage, so you will do this only. Okay. Directly you'll get the answer. So what is the value of the shunt resistance? So shunt resistance can be given by V divided by Ig minus Rg. Anyhow, this equation is important for us. Rest all we can solve. Rest all we can solve. Okay, just a minute. That's all, my dear friends. So I have done with this, my dear friends. So I think you got this. Let's move ahead. Let's move ahead. Okay. So now I'm going to talk about some basic questions related to galvanometer and some basic things, है ना, which NEET used to ask us. Okay. After that, we will start potentiometer. After completing the potentiometer, we'll start meter bits and we'll solve it. Yeah, a good voltmeter has high value of resistance. My dear friends, as I told, ideal ammeter, right? Zero shunt. Yeah, zero resistance. Zero resistance. Okay. Ideal voltmeter, right? It is having high resistance. Okay, my dear. Yeah. So that's all, my dear friends. Okay. So yeah, Rajni, something like that only. Okay, Kushi, something like that only. So let's move. calculation purpose, we use current in the ideal voltmeter is 0. So as I told my dear friends, key in ammeter, entire current should pass through the ammeter. Then only it will measure the perfect current. But from voltmeter, what should happen? Maximum current should flow through the other resistance, not through the voltmeter. Okay, so minimum current should flow through the voltmeter. Okay, so this is not so important. This first point is very important. Okay, a good voltmeter has high resistance. It is having high resistance means low current will flow through it, है ना? Resistance is high, current will be less. Yes, question in front of you. A galvanometer has resistance of G. Okay, G is the resistance of galvanometer, and the range is V volt. The range is V volt. Okay, calculate the resistance to be used in series to extend the range to NV. Now, listen, my dear friends. So we are having a galvanometer. We are having a galvanometer, and if you want to increase it range means what? Let's say it can measure V voltage, but we want it to measure NV voltage, N times of V voltage. What we will do? So simply, I'll say, let's say this is a voltmeter. Okay, no problem. So simply speaking, I am saying ki let's say resistance of, yeah, so this is very simple thing, my dear friends. You can do it easily. So what to do, my dear? So I am saying, let's say current flowing through this, है ना? Current flowing through this. Let's say this is galvanometer, okay, and one resistance is added to it in series. So initially, I am saying when no resistance is added, है ना? In that situation, you will say current flowing is Ig. Okay, it is called full deflection current. So that will be equal to whatever voltage it measured divided by, है ना? So full deflection is Ig is equals to V upon resistance of galvanometer. Resistance of galvanometer. Next, if I add a shunt resistance here, I want to find the value of this resistance so that its range becomes what? N times of V. So I will say what? V is equals to I into R equivalent. Okay, no problem. Value of this V, है ना? That is N times, है ना? Now what is that? N times of V is equals to current. Current is same Ig, and equivalent resistance, that is G plus R. G plus R means how much resistance should be added so that what will happen? Range will become N times, है ना? It will measure N times potential. Okay. So what I will do? So I'll say कि N into V is equals to value of Ig. Value of Ig is what? V upon G. So right here, V upon G into G plus R. Okay. Right. So this is G plus R. Okay. As you will solve it, you'll get the answer here. As you will solve it, you'll get the answer here. Okay. So very simple thing. You are getting value of R here, right? That is G into N minus 1. That's all. Simple calculation. You can do it. Okay. Isn't there to some okay? Yeah, there is a solution now, but now it's we can't do anything actually. Okay. Why we used to share our code? We used to share our code for that purpose only. Okay. If more and more students are using our referral codes, means we will stay for long time. Okay. If no one is using those referral codes, means we will not stay here for long time. So that's the answer. R is equals to G into N minus 1. Okay. That's all. Yeah, Krushi, I asked them, but they, I asked them, but they are not agree with that. Okay, no problem. Yeah, find the potential difference across the resistance of 3 ohm in A and B. You can say this is A, this is B. You need to find the potential difference across 300 ohm. Can you find? Come on, find for circuit number A. A, B, C, D, four options I am giving. For circuit number A, you find the potential difference across 300 ohm resistance. Come on. 30 volt, 50 volt, 60 volt, and 40 volt. Which of the following is the correct answer? Come on. Come on, you can do it. Yeah. Waiting for your response, my dear Khushi. Come on, solve it. All of you can do it. Just you need to find in diagram number A what is the potential difference across 300 ohm. So I will say the current I is equals to V upon R equivalent, right? So directly we will say what 100 volt divided by total resistance is 500, resistance is 1 by 5. Sorry, current is 1 by 5 ampere. Okay. Now I'll potential difference across 300 ohms. So directly you can say what I into R. So I is 1 by 5 into resistance is 300 ohms. So you are getting what? Yeah, 60 watt. Answer. So 60 watt is potential difference across 300 ohm in first. Very good. So please ask the team to provide you other channels. This English channel is not so famous. Okay, sir. I used to watch the lectures on Hindi channels also, but never understood physics like I understood from you. Okay. Thank you, Kushi. But Unacademy don't know about this. Okay. Yeah, so definitely the channel team they don't know about it. Even they know they don't, it doesn't matter. So my dear friends, now let us talk about diagram number P. Let us talk about this. Yeah, you need to find the potential difference across 300 ohms. What you need to find the uh, reading of the voltmeter, right? In diagram number B. Come on, give me the answer. Diagram number B. What will be the potential difference across 300 ohm? Come on. So I am giving you option A, B, C, D. Same options for 50 volt, 60 volt, 30 volt, and 40 volt. Which of the following is the correct answer? Okay, waiting for your answers, my dear friends. Come on, come on, come on. You can do it. Find the potential difference across 300 ohm in diagram number B. Circuit B. Yes, you can do it, my dear friends. Okay, Kushi gave the answer A for apple. Very good, very fast, Kushi. You are correct. So simply speaking, we can say this resistance is 200 ohm. Okay. Now equivalent of these two resistance 600 into 300 divided by 600 plus 300 means this is 200 ohm. Okay. Yes. And it is connected with 100 volt battery. So simply it is 100 volt means equal potential will be provided to what 50 volt. Answer is 50 only. Very good. Yeah, it is heartbreaking for me also. And Rajni? Yes, correct. But what can we do? Policies are policies. We can't do anything. A potentiometer is a linear conductor of uniform cross section with a steady current set up in it. Are you getting? We are going to start potentiometer. What is a potentiometer? Listen, potentiometer is nothing. It is just a conducting wire. It is just a conducting wire. Remember that. Okay. So I'll draw a wire. This is a wire. I'm saying this is a wire. Okay. AB is the wire. Now, it is a linear conductor of uniform cross section with steady current set up in it, right? Means what will happen whenever we want to use it? Whenever we want to use the potentiometer in any circuit, actually it is having multiple uses, okay? It is used to measure the unknown, EMF of unknown cell. It is used to measure unknown cell internal resistance. These all things a potentiometer can measure. Okay, but how to use it? It is yeah. How to use that potentiometer in a circuit? That is the important thing. Okay, so potentiometer how to use? So always there will be a primary circuit. Primary circuit will be like this. Primary circuit will be like this. It will have some cell E. Okay, no problem. This is some cell E, and it will be connected with. It is having some internal resistance R. It doesn't mean like simply speaking, we don't know about these two things. Okay, it is having EMF E, and it is having internal resistance R. We don't know about these two things. Okay, it is not needed. I am saying let's say length of this wire. It is needed. That is at L. Length of wire it may be needed, that is L. Okay, and resistance of this wire AB, that is needed. Okay, resistance of wire AB, that is let's say RAB, that is needed. If you know this many things, means you can solve it. Means you can solve it. Okay. Yes. Hi Neeraj. So Neeraj and this is Mohammed. Okay. So let's move, my dear friends. Okay, no problem, my dear. Good night. Yeah. So we are moving. Don't worry, Rajni. We'll find something. Don't worry. Yes. So, my dear friends, here E and R is internal resistance, okay, and it is connected with the wire. This wire is called AB wire is called potentiometer. So this AB wire will have some resistance RAB, no problem. Its length is L. That also you know. Okay, I will say potential difference, है ना? Potential difference across AB wire. So I will say VAB, है ना? VAB that we can measure. VA minus VB or VAB we can measure. Okay, that we know. Divide by length. It is called potential gradient. It is called potential gradient. Okay, remember that VAB divided by L. No, voltage across AB per unit length is called potential gradient of this potentiometer. Okay, yes. So this maintains a uniform potential gradient along the length of the wire. Potential gradient is what? Voltage per unit length. Voltage per unit length या potential difference per unit length is called. Yes. Okay. Swapnali. Okay. You are new here. Actually, I cannot pronounce your name properly. It is Tureal. Okay. Yes. So, my dear, let us talk about this maintaining uniform potential gradient along the length of the wire, right? It means what? This is entire wire AB. Okay, no problem. Potential difference across this wire is, let's say, V, and length of this wire is L. Now, in that situation, what I will do, I'll find potential gradient. Let's say that is X is the potential gradient, voltage per unit length, voltage divided by length. This is called potential gradient. Now, how to find the like voltage difference, yeah, potential difference across AB? So I will say if there was a cell, internal resistance was also there. Here is resistance RAB, है ना? So you can find the current I. You can find the current I, है ना? So you can do directly कि I current that will be equal to E upon R plus small r. This you know. Now potential across AB is what? That will be equal to E into R divided by R plus R. है ना? Array simple I into R. That's all. So like that you can find the potential. Okay. And if potential difference across AB. If you divide the length into potential difference, directly you will get the potential gradient. That's all. Okay. Yes. So let's move ahead. Any potential difference which is less than the potential difference maintained across the potentiometer wire can be measured. Are you getting? So whatever the potential difference is across the potentiometer wire, you know, VAB. Okay, so sorry, less than that, any potential can be measured using a potentiometer wire. Okay, more than that cannot be measured. Yes. So next, my dear friends, the wire should have high resistivity and low expansion coefficient. This is the important point, my dear. Remember this. For a potentiometer wire, resistivity should be high, and expansion, the thermal expansion coefficient, that should be low. Okay, so that's the thing you need to remember. So let's move ahead, my dear friends. We can do it. Yeah, so let us talk about this. I have drawn a diagram. This is, you can say, this is a diagram of potentiometer. Potentiometer is just a wire AB. It is having high resistivity and low expansion coefficient. Okay, its resistance is constant, that is RAB. I am saying its length is L. Okay, right, that's all. So now let's continue this. Okay, this is not for board, my dear. It is in board also. It is in NEET also. Okay, for both it is same only. You can understand. So I will say कि current flowing through AB wire, that is E upon small r plus capital R, है ना? Because resistance of potentiometer is capital R. And now what is the potential difference across AB wires? I will say I into R, है ना? So that is E into R divided by R plus R. Now what is potential gradient? That is VA minus VB divided by length, है ना? So you are getting this. This is the potential gradient of potentiometer wire. That's all, my dear friends. Remember. So let's move ahead. This is a simple concept. If you have done this much, means you have solved half of the question. Okay. Now let's move ahead. Question is there in front of you. There is a question in front of you. Primary circuit of potentiometer is shown in the figure. Find the current in primary circuit. So only primary circuit is shown. Find the current in the circuit. Come on. I am giving you four options. A, B, C, D. Come on, come on, come on. You can do it. Find the current in the potentiometer wire. Yeah. So let's say that is 2 by 30, 2 by 31. Next is 20 by, sorry, 2 by 3. And last is 20 by 31 ampere. Which one of the following is correct? 20 by 31. Yeah. Which one of the following is the correct answer? Current in the circuit. Come on, you can do it fast. All resistances are shown here. You can solve it easily. B. Very good. 2 by 31. It is only the correct answer. Very good. Very nice. Khushi. Very good. So simply speaking, I'll say current I is equals to V upon R equivalent. V is 2 volt and R equivalent. It is what? 1 ohm plus 20 ohm plus 10 ohm. So 31 ohm. So 2 divided by 31 ampere. That's all. Okay. Next, potential drop across wire AB. VAB you need to find. Tell me how much it is. It is I into R. It is I into R. है ना? So that is 2. This is 31. Sorry. 31. Yeah. So 2 divided by 31 into 10. So you are getting 20 by 31. Okay. Next. Very good. Potential gradient means potential drop per unit length. Are you getting potential drop per unit length? So VAB divided by L. है ना? That you need to find. So you'll say 20 divided by 31. Okay. Divide by 10 you will write. No, because length is 10 ohm. 10 meter. So you are getting 2 by 31 volt per meter. This is the unit. Volt per meter is unit for the potential gradient. Okay. Maximum potential which can be measured above the potentiometer. Yeah, so we know one thing. The maximum potential which can be measured is equal to the potential drop across wire AB. That's all. Your potentiometer AB. So you will say Vmax can be measured is VAB and its value is 20 by 31. 20 by 31 watt. That's all. This is the answer. Over. We have done with this. Okay. I hope you got this, my dear friends. So let's move ahead. Application of potentiometer. My dear friends, I am going to talk about application of potentiometer, where we can use the potentiometer the first to find EMF of unknown cell or compare the EMF of two cells. है ना? So my dear friends, just don't look at that diagram. First, look at this. I am saying ki what is potentiometer? So potentiometer, this is R, this is E, primary circuit of potentiometer. It always remains same. It will never change. It will never change. Okay. So whenever you have any question, first you remember you have to make the primary circuit of potentiometer. Yeah, me. Okay. Next, this is terminal A. This is terminal B. Okay. Yeah. Now I am saying ki it depends ki how to use this potentiometer. It always depends. It always depends what is the task. है ना? What type of circuit should be used? It depends on what is the task. So here the first task is to find EMF of unknown cell or to compare the EMF of two cells. Are you getting? Let's say you are having two cells and you want to find its EMF, you know, and you don't know its value. What you will do? So simply speaking, you will just use a secondary circuit. You will use a secondary circuit. Okay. So you have made a secondary circuit. In that you will add one known cell about which you are knowing everything. Okay. So this is E1 and this is R1. This is known. This is known to you. Okay. Yeah, its free terminal is here. It's free. Now, here is unknown cell. E2 is unknown, my dear. Come on. E2 is unknown. Okay. Yeah. So I will say E1. I know everything about it. E2, that is unknown. Okay. Remember. So the two cells E1 and E2 should be added like this. whenever you want to find the potential of unknown cell. Okay. या खुशी, हम इसके बारे में बात करेंगे बाद में, है ना? हाँ 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 कुणाल, कल रिलेटिव क्वेश्चन पढ़ाएंगे, कल 11th क्लास है ना? Yes, here is a third terminal with which a jockey is connected. Okay, what is a jockey? Jockey is nothing. It is just a conducting wire connected with a conductor. You know, like it is just like this pen. You know, so it is having some metal here and it is connected with a wire. Okay, so this is called jockey. At first, at first, what you need to do? Listen. First, you will connect this two. Okay, first you will connect this two. As you will connect with this two, and you will just move this jockey. This jockey is having a galvanometer in it. The jockey is having galvanometer in it. Okay, until and unless the current is flowing in through the galvanometer, it shows some deflection. Okay, as the current through the galvanometer becomes zero, there will be no deflection in the galvanometer. So we will just move this jockey on this potentiometer wire. There will be a point where we'll find zero deflection in galvanometer. Means that point is called balancing point or balancing length. Okay. So let's say entire length is capital L. Okay, no problem. I'm saying from here to here, L1 is balancing length. You know? So jockey is connected here. So L1 is balancing length. Okay. So at first I am saying keep potential. Yeah. X is VAB divide by L. That we know, already know. Okay, no problem. Now next I will say keep this point. Let's say this is C. You know, C. So VAC. Okay, that will be equal to what you will write? Directly you will write V X into L1. X into L1. So this is the potential drop across A and C. A is the starting point, C is the balancing length. C is the point where the deflection in the galvanometer is zero. Okay. Yes, my dear. I have added galvanometer. Okay. Yeah. So C is the point where the deflection in the galvanometer is zero. Okay. So we are getting like this. So simply I will say a potential difference across AC wire, that is XL1. No problem. Now yeah, so this thing you got, this is balancing length. This is what balancing length. Okay, no problem. Next we can do one more thing. What we can do? Similar thing. Let us disconnect this wire and connect it with the second one. Connect it with the second one. So now we have connected this with the second one. And now again you move it on the same potentiometer wire, you will get the L2 length. So you will write again same like this. So I have written everything here for you. Yeah. So E1 is equals to XL1 you have written when you connect 2 and 1. You know? So 0 deflection, 0 deflection. Okay. This you are getting 0 deflection in galvanometer. Okay. So that is called balancing length, that is L1. So E1 is equals to XL1, right? Are you getting? So I am saying VAC is equals to XL1 and it is equal to E1. Why it is equal to E1? You can see here. Listen, when no current will be there, so I am saying this is some potential difference and here is some potential difference. When these two will become equal, there will be no current in the circuit. Okay. So simply speaking, XL1 is the potential difference across AC and that is equal to the EMF of first cell. Okay, so I am writing XL1. That's all. So XL1 is equals to E1. Okay. Next, similarly, you will do for the second cell also. For the second cell also, so you will write what? E2 is equals to XL2. Okay. E2 is equals to XL2. Just equate this both. Yeah, put the value of X. Yeah, take its ratio. That's better. E1 upon E2 is equals to L1 upon L2. That's all, my dear friends. If you, as I told you, L1, L2, you are knowing, you are just moving the this jockey on the wire. So you will get the value of L1, you will get the value of L2, no problem. Okay. You know the value of E1, but you don't know the value of E2. So finally, from here, you will get the value of E2. E2 is equals to what? E1 L2 divided by L1. Okay. Did you understand? I hope you got this. If you did not understand, once again, I am explaining in short. Let's go through it in short. Listen. Let's say I have a primary circuit. Okay. This is potentiometer wire A and B. No problem. Now I am just using one cell, that is E1. Okay. And this is galvanometer and this is jockey. I'll move the jockey. I am finding the length L1 where the deflection in the galvanometer is 0. So I will say okay, whatever potential difference is there across this wire, the same potential difference is there across this cell. So in that situation, there will be no current through G, you know, because there is same potential difference across this wire and this wire, means no current will flow. So simply I will say what? I'll say VAC is equals to E1, है ना? That is equal to E1. And I know one thing, potential gradient in the wire AB, that is X, so X into L1, है ना? So VAC is equals to X into L1 is equals to E1, right? Next. Similarly, you will do with the second circuit. So for the second circuit, same thing is there. Forget the first one. So you will do with this. Now E2 is there and you are getting balancing length at some L2 length. Okay, this is E2. So same you will get. So that will be equal to X L2 is equals to E2. Just take its ratio. You will get L1 upon L2 is equals to E1 upon E2. You know the value of E1, so definitely you will get the value of E2. That's all. Okay, my dear. So that's all we have done with this. Now let's move. We can solve the questions easily. Now there is a question in front of you. Come on, try this. Try this. You can solve the question, my dear. Okay, you are asking how to find the jockey value. My dear, jockey value we don't need to find. We will just move this jockey on the wire. We will get the zero deflection in the current. So we'll get the balancing length. Okay. Okay, today Nitesh sir did not took the class. My dear Rajni, Kushi, Nitesh sir will take class. At least for 2 months he'll take class. Don't worry. Okay. Yeah. So in the experiment to determine the EMF of unknown cell, एक unknown cell का EMF आपको find करना है ना? Compare with the standard. So directly you can do how you will do. So E1 upon E2 will be equal to L1 upon L2. Okay. In the question it is given a standard cell is there 1.12 volt. Okay, you have written here. Now unknown cell, let's say that is E2. I don't know about that. You are getting balancing length is obtained 56 and 80 centimeters. From here 56, here 80. What you are getting E2, है ना? Yeah. You solve this 56 into 2 times, है ना? Right? Are you getting? So you are getting here how much? We are getting here 0.02 volt. Okay. Finally, what you will get? So 1.6 volt is the answer. So this is the EMF of unknown cell. That's all. Okay, my dear friends. So that's all. You can do it. Next. To find the resistance of unknown resistance, you know, let's say you are having a circuit like potentiometer, right, and you want to find the resistance of unknown resistance. How to find the resistance of unknown resistor? So you have what you have primary circuit. Okay, so let's say it is connected as shown in the figure. It should be connected like this only. Okay, yes. So what you will get? So simply speaking, my dear friends, if there will be no current through galvanometer, there will be no current through the galvanometer. In that situation, I will say that the balancing length is L1. The balancing length is L1. Okay. Yeah. So let's say R1 is known and R2 is unknown. Let's say R1 is known and R2 is unknown. Okay. Any one cell you can take that is unknown cell. Okay. Now what next? Listen. I am explaining this properly. Listen. Hey guys, here you are getting zero current. Here current is zero. You know, here current is zero. Why? Because here current is there and it is moving like this only in the same circuit. In the same circuit, current is moving. It is not going in the galvanometer. Okay. And here in this also current is available. That current is moving like this. Okay. It is not coming in the galvanometer or lower circuit. Okay. Why? Its reason is whatever potential difference is there in this much length. Okay. The same potential difference will be here. Okay, the same potential difference will be here across this resistance. So that's all I wanted to say. So this is R1, this is R2. Now you can find it easily. Now you can find it easily. So what you will do? So you will say कि for this balancing length, है ना? So yeah, so directly you can find it, है ना? For this lower circuit, let's say current is I. Here current is I. So I into R1. Okay. थैंक यू माय डियर। I into R1 मैंने बोल दिया क्या कि इट इज पोटेंशियल डिफरेंस अक्रॉस, या यहाँ पर मैं बोल सकता हूँ कि I into R1 इज द पोटेंशियल डिफरेंस अक्रॉस R1, है ना। एंड सेम पोटेंशियल डिफरेंस A एंड C के अक्रॉस भी होगा, देयर विल बी द सेम पोटेंशियल डिफरेंस अक्रॉस A एंड C, दैट विल बी XL1, दैट विल बी XL1, ओके माय डियर। या यस, so now what can we do, my dear? I R1 is equals to X L1. This you got it. Now the second relation. You can do one thing, my dear. You can find the value of current here. You can find the value of current here in the lower circuit. This current will be there only for the lower circuit. So you will get the current in the lower circuit. I is equals to X L1 upon R1. Okay, right? Because you know the value of R1, so you'll get it here current. You got the current. Hey guys, you got the current, my dear. If you got the current, what can you do? So you can use it for the R2. Means what? You can write it like this. E should be equal to, sorry, I should be equal to E upon R1 plus R2. Okay. तो आपने क्या किया? ये सिर्फ नीचे वाले सर्किट की बात कर रहे हैं, करंट सिर्फ नीचे वाले सर्किट में ही फ्लो कर रहा है, ठीक है। सो हम बोलेंगे कि करंट फ्लो होगा नीचे वाले सर्किट में, तो E अपॉन R1 प्लस R2 हम लिख लेंगे, है ना। इसका मतलब ऊपर करंट जा ही नहीं रहा है, तो इसका मतलब व्हाट विल बी द रेजिस्टेंस, यू विल से कि potential difference across AB, we know that that is IR1. Potential difference across the second resistance, that should be IR2, and sum of this both should be equal to what? B, na? Sum of this all should be equal to E, right? We'll get the value of R2 directly. Okay, once again I am explaining, I think you are having confusion, so listen. Once again I am explaining, listen. You are having this diagram, particular diagram, okay? Yes, so listen how to do this. So I am saying key, let's say this L1 is balancing length, so current in above circuit, it will be flowing like this only, no current is there in galvanometer, zero deflection. Here current is I, okay, no problem, current is I only and flowing the same in this. Okay, now what can we do? We are having two circuits, हमारे पास दो circuits हैं, अब मैं कैसे deal करूँ इनके साथ? तो बेटा मैं बोलूंगा I will say कि VAC है ना, VAC is equals to XL1, no problem, we can write like this. Okay, we know the value of X, we know the value of X already. Okay, next in the lower circuit I will say कि potential difference across R1 is equal to potential difference across AC for zero deflection, right? So I will say that will be equal to, है ना, so that will be equal to what? DR1. That will be equal to I into R1, right? That will be equal to I into R1. Okay. So I will say this both are same. So XL1 should be equal to IR1. Okay. This is the first relation you got. This is the first relation. ये आपको पहला relation मिला है यहाँ पे. Okay. What next? What is the next thing? Let's say R2 is unknown. You don't know R2. This is R1. Okay. Yeah. R2 is unknown. You want to find the value of R2. So now how you will find the R2 value? Okay. So simply speaking, we all know value of E. Okay. So E is equals to I R1 plus I R2. We are having value of I from the first equation. From this equation, you find the value of I and put it here. You will get the value of R2. So you can find the easily value of R2. You will find easily. That's all, my dear friends. You know, right? So R2 can be given by E upon I minus R1. That's all. So like that, you will get the value of R2. That's all, my dear friends. Very simple concept. Okay, at first you find the potential gradient just using the upper circuit, primary circuit. You got that. Okay. After that, you will say okay, balancing length means potential difference across AC will be same as potential difference across R1. Okay, means XL1 will be same as VR1. है ना? So we will write XL1 is equals to IR1. Okay. So you got the value of I. Now what to do? Just observe the lower circuit, in that current is I. है ना? Yes. So directly we'll write I R1 plus I R2 is equals to E. So you'll get the value of R2. R2 is Z1. You got that. Khushi, there it is not possible now. Like there is no solution now. Hi Afra. There is no solution now. I can't do anything. Like hey, we'll talk about the solution in the last class. Okay, Khushi. Still we have two classes. Now we'll talk in the last class. Okay. To find the internal resistance of cell. To find the internal resistance of cell. How to find the internal resistance of cell? So my dear friends, let's say I have some cell having internal resistance that I don't know. Okay. So at first I'll take first arrangement, then I'll take second arrangement. Two arrangements I have taken. Okay. Right? Yes. So my dear friends, so I have to find unknown internal resistance of the cell. So first arrangement you can see, right? Second arrangement, you will add a known resistance in parallel to that first circuit. Okay, that's all. Now, simply speaking, there is no current through galvanometer. है ना? In first situation, in first condition, you will get X L1. है ना? That will be equal to what? That will be equal to no current should pass through it. Means that should be equal to E dash. X L1 should be equal to E dash. No problem. In second arrangement, you can see current will flow definitely, but current will flow like this. Okay. Yes. It will not go to galvanometer. So directly you will say what here in second circuit. You know, in second circuit, you can find everything unknown resistance you need to find, right? Yeah. So anyhow, I have written here everything for you. First circuit E dash is equals to XL1. Second circuit I into R is equals to XL2. Are you getting? As I told, current is flowing in this circuit, right? Only in this circuit current will flow. It will not go to upper circuit, right? So I current is flowing because in that zero deflection, you know. Yes. So now I'll say what potential difference across this branch. Potential difference across this branch is I into R. I into R. Okay. And the same potential difference will be across this branch also. Okay, no problem. And the same potential difference will be across this L2. L2 leg. है ना? So directly you will write I into R is equals to XL2. I into R is equals to XL2. Okay, my dear friends. Yes, my dear, diagram must be remembered to solve the questions, okay? Diagram must be remembered to solve this type of questions, okay? If you are having a good luck, you will get the diagram in the question itself. If you are having bad luck, they will not give any diagram, okay? Kushi, don't worry. Still, we have two lectures now. Well, enjoy, don't worry, okay? So, finally, I can say that IR is equals to XL2 and E dash is equals to XL1. Directly just put the value. So, we can say what? In this circuit, secondary circuit, you know, in the secondary circuit, this was R, this is small r, and this is E. So I can write what? Current I flowing through it is what? E upon R plus R. That's all. So this is the current flowing, right? This is the current flowing in the secondary circuit. Okay, my dear friends. So that's all. Yes. Okay. And we know that will be equal to what? You can see here. E1 is equals to XL1, that will be equal to yeah, IR is equals to XL2 और वही किसके बराबर होगा, that will be equal to what? Yeah, so you know this thing, so no need to worry about that. Just use it directly. Anyhow, just for potentiometer, you need to remember this. Whenever they will ask you what is the unknown internal resistance, you use this only. R is equals to L1 minus L2 divided by L2 into R. Okay. That's all. You use this formula, you'll get the answer. Why to go for that long derivation? You know? Okay, sir, my last chance to get selection. How should I not worry? Definitely, my dear. Afra, sir, in thumb lines and description, please include topic names with the. Okay, topic names with the chapter. Okay, my dear. So, Afra, tomorrow and day after tomorrow, 2 days relative motion chapter will be there. Okay, relative velocity and all. Yes. खुशी मन के हारे हार है, मन की जीते जीत. तुम्हारे मन में यदि लाइक पॉजिटिविटी है ना, तो तुम कर सकते हो, किसी की जरूरत नहीं है ना. तुम्हारा सिलेक्शन तुम पे डिपेंड करता है, तुम्हारी मेहनत तुम पे डिपेंड करती है. ओके, टेंशन नहीं लेने का, मस्त रहो, अच्छे से पढ़ाई करो. ओके. Yes, Khushi, that time I was not knowing about this. I got that information today itself. Okay. So just internal resistance we can find using this L1 minus L2 divided by L2 into R. Now, we can solve some question also based on this. We can solve some question also based on this. Okay. So let us solve. Let us solve a question. This is internal resistance. This is some battery having, let's say, its resistance is, let's say, some its voltage is 10 volt or something. We don't know. Okay. Now what will happen? Here is a resistance R that, let's say, that is 5 ohm. Let's say that is 4 ohm or 5 ohm, whatever. Yes. And here is a key. Here is a key. Okay. Here is a key. Yeah. The question is, this length is, let's say, 1 meter. This length is, let's say, 100 centimeter you take. Okay. Yeah. So I am saying when key is open. Key is open. Balancing length L1 was 40 centimeter. Okay. When key is closed, then balancing length L2 becomes 60 centimeter. Okay, 60 centimeter. Yeah. Then find value of internal resistance. Find value of internal resistance. Come on, find it. So how to do this? This is 4, my dear. This is 4. 4. Okay, this is 4. Yeah. So now how can you solve it? So simply you can solve it. R is equals to L1 minus L2. Yeah, mod of it. Yeah. Let's say, okay, we have added in parallel, right? Yeah. So I am writing here, this is 60 centimeter. L1 is 60 and L2 is 40. Anyhow, it doesn't matter. You can take modulus of that. So no problem. So you can write it 60 L1 minus L2 divided by L2 into R. Okay, put the value. 60 minus 40 divided by, yeah, here you will write 60. Sorry, 40, 40. L2 is 40 into R. R is how much? R is 4 ohm. So directly you are getting the answer. Answer small r is equals to 2 ohm. That's all. This is the answer. Okay. Yes. So that's all. This is the answer of this question. So simply, whenever unknown resistance you need to find, you can use this method. Just you remember this formula: L1 minus L2 upon L2 into R. L1 is balancing length when external resistance is not connected, and L2 is the length when external non-resistance is connected. Okay, so you'll get the value of internal resistance of the cell. That's all. Okay. Yes, got this. So this second concept we got, internal resistance. Now, yes, so I hope you are getting this right. That's all we have completed. Now let us talk about the meter bridge. What is the meter bridge? My dear, meter bridge is shown in the diagram. You can see it is such type of construction. It is such type of construction. So I am explaining this once because I cannot draw it, so I have just kept it. Yeah, meter bridge, potentiometer. Yeah, so meter bridge works on the principle of Wheatstone bridge. Okay, remember, meter bridge works on the principle of Wheatstone bridge. Okay, what will happen? Listen. So you will say that you are having this type of a metallic plate here. One resistance box is connected. Resistance box is connected means there will be a non-resistance. Means you are knowing what is the resistance of the resistance box. Okay. Now here is unknown resistance. Okay, so always you will use unknown resistance here. Okay, and this is the wire, just like potentiometer wire. This is a meter pitch, so it will be 1 meter length wire. Okay, so my dear friends, it is a wire of 1 meter length. Okay, so 1 meter wire you are using. So same concept. Below that you have attached one cell. So means this wire AB will have some potential gradient. It will have some potential gradient. Okay. Now what you will do? You want to find the value of this unknown resistance. You want to find the value of this unknown resistance. So what you will do? This is the D point from where what is connected, a galvanometer connected, and it is just moved. It is just moved on this lower wire, like this AC wire. You know? Yeah, meter bridge wire. So you will find somewhere you will find zero deflection in galvanometer. Means there is no current passing through galvanometer. So I will say that this is just acting as a Wheatstone bridge. You can see here P is resistance box. Q is, yeah. Listen, my dear. You can say R is resistance box. X is unknown resistance. P is this AB. P is just AB and BC is just this Q. Okay. BC is represented by Q. You can see here AB, BC, right? So resistance of AB is P, resistance of BC is Q. That just I am saying, like, just for information I am telling you, okay, we can use like this. Okay. Actually, my dear Churail Mohammed, my dear Simple, listen. Actually, always without external resistance, so in potentiometer you will get the first length more. Okay, my dear, you will get first length larger. L1 always you will get larger only. Okay, L1 always you will get larger only. Okay, my dear, listen, you will get always L1 larger in this. In this, always you will get L1 larger. Okay. By mistake, I have given there low value, but after that I corrected it, right? After that I corrected it. You will always get L1 larger than L2. Okay. Yeah. Here, let us talk about it. So AB is having resistance P and BC is having some resistance Q. Okay. So it is just working on the principle of Wheatstone bridge and it is having balancing length. Okay. So you will say कि no current will pass through galvanometer. So just solve it like a Wheatstone bridge. Okay. So you will just solve it like a Wheatstone bridge. You will get the answer. Okay. So how you will solve? So listen. We all know if this is resistance R, no problem. Here is galvanometer G. This is resistance X that we don't know. And now here we are having AB and this is BC. Okay, this length, entire length will be always 100 centimeter because this is meter bridge. Meter bridge means this is 1 meter means 100 centimeter always. So you will say this length is, let's say, L1. This length is, let's say, L2. Okay, no. So L2 is L 100 minus L1. है ना? So you can write this is L and this is 100 minus L. No problem. Okay. And we all know one more thing. Resistance is proportional to length, right? Rho is R is equals to rho L by S. So resistance is proportional to L. Okay. So you will write this is P resistance, this is Q. So R upon P should be equal to X upon Q. You all know this, right? Wheatstone bridge. Okay. So R, so what you will write for R? R is R. It is given in the question. L, sorry, P, you will write here L only. Okay. For this, what you will write? Here you will write X. X is unknown. And for Q, Q you will write 100 minus L. Okay. No problem. You will get the value of X here. 100 minus L upon L into R. You'll get the value of unknown resistance. That's all. So this is the concept for solving this. Okay. I hope you got this. I hope you got this. Okay, my dear friends. Yes. Yes. If you got this, please give thumbs up. No. Khushi, meter bridge is not always balanced. We used to find the balancing length. आपको समझ में आ रहा है बेटा? हम लोग क्या करेंगे? ऐसी चौकी को इधर उधर घुमाएंगे, ऐसे इधर उधर चौकी को घुमाएंगे, तो मुझे अननोन रेजिस्टेंस चाहिए, तो उसके लिए बैलेंस करना ही पड़ेगा, है ना? डिफ्लेक्शन जीरो लाना ही पड़ेगा। तो आप क्या करोगे? उस वायर पर इधर उधर ऐसे घुमाओगे, तो एक पॉइंट मिलेगा। ए से कुछ लेंथ बी, मतलब बी पॉइंट की कुछ लेंथ मिलेगी, जिसके लिए गैल्वेनोमीटर में कोई करंट पास ही नहीं होगा, जिसके लिए गैल्वेनोमीटर में कोई करंट पास नहीं होगा। ठीक है, तो इस कंडीशन में मैं बोल दूंगा कि गैल्वेनोमीटर से करंट पास नहीं हो रहा है, मतलब ये बैलेंस हो गया, है ना? So it will behave as a balanced Wheatstone bridge. Directly you will write R upon P is equals to X upon Q. Yeah, so you will get this type of formula. That's all. Very good. Okay, my dear friends. So we have done with this. So now I would like to say bye bye to you all. It's sufficient for today. You know? Yeah. So just one last day is remaining. Tomorrow evening 6 p.m. the prices will rise. You know, prices of Unacademy subscription will rise. Still my code is valid till 31st. Okay. So if you want, you can use this code and you can get the Unacademy subscription. You get the 10% discount. But if you get, but I am telling you, if you want to get an academy subscription, buy it before tomorrow evening 6 p.m. Okay, after that prices will increase. You need to pay more after that, है ना? Yeah. So either you don't get, and if you wanna get it before 6 p.m. Okay. Yes, my dear friends. So now I would like to suggest you, my dear friends, listen. All strengths are there in you. Okay, it is hidden in you. You can do anything. Those who are toppers, they are taught by some teacher, and some student who is in the same batch is not selected. He is also taught by the same teachers, but still he is not selected. Why? Because there is difference in preparations, there is difference in willpower, there is difference in your belief, right? So simply speaking, मन के हारे हार है, मन की जीते जीत. Okay, मन को कभी हारने नहीं देना है. Okay, always be stronger, right? Believe yourself, you can do anything. So see you tomorrow and day after tomorrow. Bye bye, my dear friends. Good night. Time, my dear, 9 p.m. Tomorrow 9 p.m.